feature engineering is definitely novel. Even one or two very thought out, intricate features, which are domain specific, can help the model do much better, right? So for example, all computer vision models today are trained on detecting a bunch of random things. Let's say, for example, you train a model that specifically looks for pupil dilation, right? You engineer a feature that looks at a computer vision like of an animal and looks at its pupil dilation and uses the pupil dilation as a feature in order to identify the animal. If you can do this successfully, then you will have a clear benchmark to say, like, you know what, by adding this specific feature of pupil dilation into my computer vision model, I was able to achieve a 3% improvement in accuracy on a data set that's already there, like a cocotherm data set with like 200,000 images. Right? So feature engineering is super important. Constraint, cost, and complexity. This is always the standard, right? So if you build a model that can perform as well as the previous model with a limited set of constraints at a lower cost with lesser complexity, then that is definitely like novel and groundbreaking. Definitely go after that. And sometimes you've got to pair all of this with like statistical rigor. Just claiming that my model is 3% better doesn't mean anything. You have to actually hit with statistics to prove that your model is indeed 3% better. And that is a statistical rigor that goes for everything above. Okay.